Hello everybody, my name is Roman Rokytskyy. I'm involved in Firebird project on the Java side, for those who don't know me. We are going to talk about the same tools that were presented by Thomas. I was afraid that this is a duplicate session, but the level, it's just a different level. We will go probably a bit deeper into the products that we have. The talk is about what open source tools do we have for a business intelligence environment. And I will, at the end, we'll end on the Pentaho suite of the applications, and we will go deeper into the tables that on the features that we have there. There's just a small overview of what features or what aspects of the BI business intelligence do we have when we talk about the different applications. Thomas made a perfect description, so it's just like to repeat again with probably some more details. I will then talk about what open source tools do we have there, and then we switch to the tools. I have disabled few slides, but I will enable them again. Probably it will go better. So the similar picture as presented before. On the left side here we have our data sources in different data formats. Then the task that you usually have is to get the data copied from your systems, different systems, probably distributed all over the enterprise, different geographical locations and so on, to get them on one place in order to start loading the data into the data warehouse. One of the reasons to get data into the staging area is, first of all, you want to have a consistent state of the data that you are loading into the data warehouse. If you load data from two independent databases, usually you design the copying process in such a way that data which are loaded from two independent systems, you coordinate the two systems where they make some kind of a checkpoint in a coordinated way. And then you extract the data for a day. For example, one system has all the updates to the customers table, another system has all the updates to the, let's say, sales information table, and then you extract things to the staging area, and you avoid the situation where you can take the data from, for example, sales information without having the appropriate records on the customers table, because you extract the customers tables, for example, in the morning, and you extract the sales information in the evening, and probably new customers were added. Also, this part is designed in order to overcome the network latency issues and so on. If you have data somewhere over there, over the dial-up line or DSL connection, any query executed against the remote database just to extract data will definitely take longer when compared to the case where you transfer the whole database snapshot or the data snapshot to a local system and then perform the queries locally. In the staging area, you might do, but you are not required to, you might consolidate also the data formats. So you can, it's a question of how you design your transformation process, whether you first transform data to the common denominator and then start to load them into the data warehouse, or common denominator is, for example, if you have different comma-separated values files differently formatted, or you have different XML files, but it is possible to transform them with simple tools in such a way that they will you will get the same format of the data, then you might consider this. It's the question how you are going to maintain that on the database system. Then we have the ETL process, extract, transform, load, which, as Thomas showed already, transforms the data into the data warehouse. The commercial tools have also additional part that is run in their so-called metadata repository, where so-called metadata, the description of this part for the different jobs is stored. Also the human readable formats, because people that are doing this job are not the same people that are doing this transformation, and to get them to the common understanding of the fields is also required. Then you have another process of transforming the data in the data warehouse format into the cubes, which is usually these roll-up parts. And on the cubes you execute your all-up queries, and then you can generate the reports or do the analysis with the all-up tools or do the data mining. This picture shows basically approximate processes that are performed on which part of the data warehouse part. One which we did not talk about is so-called data cleansing. It's the process to make the data, to perform all the necessary transformation in the data values so that they all fit together. For example, the consolidating of the IDs from different data sources. And now we come to another part. That's basically an overview of which open source tools can be used to support that or another parts of the system. The green part is the Pentaho suite. The nice thing about their product portfolio is that they cover pretty all parts of the data warehousing processes. For the extract, transform, load, there is another very often compared with the Pentaho data integration tool. This is the Talent Open Studio. They have two different concepts. The data integration is a tool where you model your transformations and jobs in the graphical designer, and it is stored in some definition file, and this definition file can be later executed by a process by the runtime engine which performs the transformations. The Open Studio is a bit different. What they do, you also have the graphical user interface where all the transformations are modeled, and approximately similar to the data integration. Bit different components, but the idea is the same. However, the Open Studio generates the execution files. It can produce the transformations either written in Perl or in Java language, which then can be compiled into an independent component and executed. For a case of Java, and in Perl you don't need to compile that. Comparing the performance, there's different reports. Generally, OpenStudio, the transformation performed by OpenStudio are faster than data integration. However, the time that is needed to get all pieces together and to start the start the ETL process with OpenStudio is usually, for the end users, which are not the developers, is higher. I have presented to our customers the data integration in a project in a bank, and basically it was one presentation that took 1.5 hours probably, and then about 1 hour they played together, played with the tool a bit, and they were ready. They could perform their transformation. They can do things further. That's not the case with the Open Studio. So the question is basically, if you want to give the tool to the less skilled users, or to the users where the time to market, so to say, is really important, then you take data integration, where the performance is much more important, or the transformation that is needed is quite complex, and you have to write your separate tool code. Then the Open Studio might be the good case. Then what was described here is the Pentaho analysis. That's the Mondrian part. That's the all-up engine, which executes the all-up queries against the defined cubes. I will show you the user interface, how the cube can be defined from the existing database table. The data mining tool is about the detecting different patterns in your data, and to probably detect some hidden trends or something like that. That's a completely different area of the analysis. It's not just pure reporting. This part is about generating the reports on the system. The Aggregation Designer, that's what Thomas explained about the aggregation table. There is a tool also from Pentaho, which allows you, based on the cube definition here, which allows you to design the different aggregates and to produce the SQL statements to populate that aggregates. It's just a convenience tool, but it's quite useful. We will also come there. The Jasper reports and the Bird, that's basically two reporting components that are, it's basically the two reporting components for the Java. Both are able to generate PDFs and HTMLs with the data from the database tables. The main difference between the Jasper reports and Bird is that Jasper reports, conceptually, when you start to design your report, you basically design a report on a fixed page structure. It is very useful when your final report that you are going to produce is some kind of paper that you are, the PDF or something that you are going to print. The Bird has a bit different concept, which goes rather in the direction of the endless paper. So it's very useful for if your primary report generation part is the HTML pages, which can be scrolled down there. And both can be splitted on the pages, both can be printed later on, but the interaction, how you design the reports, they are different. So let's go to the Pentaho suite. What you usually do, the numbers here, 1, 2, 3, 4. Well, in a circle, it's very hard to tell where is the beginning of the circle. So it's hard to say where you should start, whether to define your cube first and then do the transformation, or you start with the transformation, then you define your cube, and then you define the aggregates and so on. It's, as I say, it's hard to tell where the beginning of the circle is. But the data integration part is about loading data from different data sources and saving them into the Snowflake or Star Schema data. The Schema Workbench is a user interface component that allows you to define the cubes and the dimensions in the XML file that was showed by Thomas. After some experience, having some experience in that direction, probably defining that directly in the XML is the easiest way. But on the first steps, the Schema Workbench is quite useful tool. This is a screenshot of the web application done with JPivot. That's a project that, so to say, the easiest or the light version compared to the OpenEye suite presented by Thomas. The difference is that it comes directly from the Pentaho. However, for the Enterprise Edition, they have new component. I didn't try it because we are rather concentrated on the ETL part in our projects. And the Aggregation Designer, that's the tool which allows to, based on the cube defined here, if we get performance problem executing the queries on here with the XML queries, then we can improve the performance in Aggregate Table Designer. And the SQL statements that, as a hint, are showed here can be later on integrated also in the ETL tool. Thomas presented the idea of running the aggregate populations in the triggers, but the integration with the ETL process in the kettle is also an option in that case. We are going to have a small hands-on session here, and I will start the kettle and show how to configure a repository with the job and so on with the Firebird. I have already created this, so that will not be one-to-one hands-on session, because then I would need to redesign all the transformation that I have there from the scratch, which is just time-consuming. But normally you have just create a Firebird database, an empty one, and you start the application it's called Kettle. I have already started it. We start from the very beginning. When it starts, for the first time, it asks about the repository. The repository is the place where the tool stores all the transformation you define and jobs you define in the tool. It is possible also to start without the repository. In that case, the transformations are stored in the XML files on the file system. The advantage of the repository, especially if you buy an enterprise version of it, is that multiple people can work on the same repository. So one can define a transformation, another one can define another transformation, and the third person can define a job that uses all that transformations. They have also the locking of the transformations and some kind of a versioning mechanism. It's not as convenient as using the CVS or Subversion for the file system. The advantage or disadvantage between the database-based repository or the file system-based no repository you have to discover for yourself in your project. There is no general solution. Normally you have to, if you don't have the repository, you say you need a new repository and you have to define a new connection. They have already the JDBC driver there, so by default they select Oracle, but you just select the Firebird there. You provide a host name, localhost, the database name. It can be alias or it can be the full path. The username, and you have to name the connection before you can tell before you can test whether it's okay or not. It says okay, then you can press OK, and then you have the connection there. I have already the connection there, so I'm not going to define it again. If you need to connect to a new repository, or if you have already created a repository on a server and you start another instance on another computer, then you define the connection here. You can you define the name and you don't press the create or upgrade button, but you just press OK and you will be able to use already existing repository. If there is no repository, then you have to create or upgrade the repository. In that case, if there is no repository, it will create a repository in the database. By default, the password is admin here, and it opens all the connections. When you start with an empty repository, it starts with, in design mode, with a transformation. So you can start the new transformation, file new, and then you can design the transformation. The transformation usually begins from the input. It needs to get somewhere the data and produce the output. There is usually no transformation that is performed without outputting any data. And then there is different parts that can be bind together about reading the data and so on. So I have there already prepared some transformation. We are going to open them, and what do we have? The transformations. We are going to generate data. I need to check what transformation is used in MySQL. The example jobs that I present here are the idea is the last job that I want to present is how to match the data with from 3 different data sources. I will match data from the Firebird database, from MySQL database, and from the Access database. But before I do this, I created a job that first populates the data in the Microsoft in MySQL database. So that's the job that creates a database in MySQL database and then uses this transformation to puts the data in there. The transformation looks like this. It's quite simple transformation. It takes data from one database and outputs data into another database. It is quite generic part. It can take as a parameter the table name, and it outputs into the same table name in the MySQL database. The connections here are created the same way as you have seen when connecting the repository. All databases can be accessed there. So we run the job here, and when it's executed, it tells which step was executed where. It's a small protocol. There is also the logging part, a bit chatty. One can disable that part and there will be less information there and the job will be executed faster. We have now the data in the database table called customer. As you see, I have started the transformation with a parameter which I say customer table, and the same transformation can be reused all the time, and you can have one transformation and just pass different parameters and transform data to the MySQL. The next transformation that we are going to check is I also prepared the same part with the Microsoft Access database. We are going to check the transformation with the matching data from the different databases. So we have our Access database there. Yeah. Quite a lot of tables I put there, but we use only one. It's the table FBCon 09 orders, which was generated. What we have there, the order ID, product ID, promotion, and so on. Tables. What we are going to do is perform a lookup against the MySQL database to fetch the user card information, the card number and the additional information from the MySQL database. Let's say this is our master database for the user-related cards. What we are using here is the step called database lookup. Here we select all the fields that we are interested in from the table FBCon 09 orders, and all these data are passed into the database lookup table, which uses the customer table information and uses the card ID, which is copied into databases in order to fetch the information about the customer ID, which we don't have on our orders table. Then what we are going to do next is we are going to populate our dimension table, and we need to fetch the ID of the dimension from our Snowflake table, from our star schema for the time dimension. That's where we perform the match on the time ID in order to put the table into the facts table. And we store the data into the sales fact table in our Firebird database. A nice thing is that if you don't have, for example, the table here, you can press the SQL button, or you change somehow the table, then it will provide, if there is no table, it will provide you the create SQL table with all field definition and so on. And if you change the types of the data columns and so on, it will give you the hints about what should be changed here. Basically, we are not going to change anything because the types will be compatible there. We start the transformation. So it reads from the access and writes to the output. That's how many records were written there. The performance, it tells also the performance of the read access. Then the next step that we have here, it doesn't fit the screen, and I cannot switch it off. It performs the first database lookup on the rate performance of 1900 records per second. Then these two steps, select values, are only in order to filter some columns that we don't need on the further steps. They are not really needed. And then we have the third step, database lookup, which had a performance 1500, 76 records per second, and then we output it to another database table on the performance rate with 1547. We see that we were able to read the data on a faster than we are able to write, and the performance degradation happens here on all these database lookup parts. That is quite expectable because what it does, it executes for each record coming from the data stream here. It executes a database lookup statement and then picks the required values and pass them further. Again, you have the time to execute data for each record and so on. There is a possibility to optimize that part, and that's another transformation which I want to show you, is to merge the information using the join. The transformation is a bit complicated, but it's almost one-to-one implementation of how our Firebird processes data from different tables when performing the joins. If when you do the select the inner join or the outer joins, the Firebird uses algorithm called match join operation. It requires that two streams. It is the algorithm to effectively merge two streams based on equality of some fields. And the requirement for this algorithm is that streams that are coming into this merge join component have to be sorted. That's why we were required to put the sort by clauses, really very similar to what Firebird does. Then we have the join component, then we need to sort this part. Again, we have another sort, then we join it again, and output to the table. So the definition of the sort by is you just specify on what you are going to sort. That's the column on which you are going to join as well. And on merge join step, you specifies the condition. From two streams, you are going to join on these two steps. Again, since we are going to join on the date value, we have to sort the streams again, and we join them again with the type inner, and then we output to the outer table. So the previous step transformation, 1500 records per second. Let's check how fast is this part. You see, these steps are not performing anything. At the moment, what it does, it fetches and caches all the data first from the access in some temporary storage. It is possible to tell him to cache the data in memory or on the file system. And then it executes the other steps pretty in parallel. And what we have, it's still running, that's the output, table output, is the bottleneck, so to say. We get the 2,500 records per second there, the performance. But some steps were able to execute even faster, and that one, which is the getting information about the customers from the MySQL database, because it's a relatively small table, only 10,000 records, just fetched everything into memory and kept it there and then joined with everything. So that's the power of this tool. Basically, you are free to implement different transformation here, and you can do them really effective, and you can the match data from different data sources. I'm going to go through the particular parts, but if you see which kind of data sources you can join, you can take data from the Excel files here, you can take data from the Access database, you can take data from whatever JDBC data source you have, comma-separated values, fixed length text files, and so on. Same with output. You can output to Access, depends, in some cases might be needed. Excel, never used it, but the main idea is that you put the data into the JDBC database, whatever that is. You can also use these insert or update statements, which are going to update data in the database, not simply perform the insert. Back to the presentation. What we have here, that explains what we matched here. We had the orders in the Access database. That could be some kind of or some database where we have only the cut information from some point of sales terminal where only the cut information is stored there. Why is jumping here? The customer information is usually quite sensitive information. It's stored only one place. Well, in our case, MySQL. Probably not the best solution, but for the showcase it's okay. And we populated the Firebird data warehouse database. So what possibilities do we have there? Is that on the transformation, the most common transformation steps that you have in order to change the values that are coming in the stream, we quite often add additional constants to the stream that basically depends on the data input. When we load the data in our projects, one of the examples is to load the data from different exchanges then some fields in the output are constant in that case. Per exchange, for example, the exchange ID and so on. You just add the additional constants there. You can enumerate records with the sequence numbers. You have the sequences that can be resetted to 0 if a value in some another field in the stream changes. So that's like a generating chapters. You have one counter that enumerates level 1, and then you reset the another counter on to get the 1.1, 1.2, and so on. The calculator component, simple computations there, replace text in some field, used quite often. The select values is if you filter, you get a lot of fields as the input, or you join when you perform the merge join, then you get a stream with all fields from two streams, and that might be hundreds of fields, hundreds of columns, or several hundreds. You don't really want to manipulate them in later steps with that many fields. You simply just perform, this is like a select and the list of columns part. You can sort rows that we saw, and you can do the value mapper, which is also quite often used if databases have used different IDs, different databases use different IDs or different constants for the same thing. The easiest or the simplest example is that the Boolean column. In one database you can store 1, 0, and in another database you put yes, no, and yet another database you can have whatever and null values and so on, and you just replace and match them together into one thing. That's I didn't translate it into English. Bad for me, but we have talked about that. That's the different inputs. What you also can do is, as a transformation step, you can execute some script. You can execute some SQL script. I didn't use that, but what is quite often used is the JavaScript value, to modify the values of some data using the JavaScript. The issue is that the transformation steps or calculator on there is quite limited. It's suitable for the simple computation, but it's not really suitable for some really complex computation. And with the JavaScript value, well, you have the full power of JavaScript. Basically, you can also here in JavaScript, you can import Java classes and perform the computation in Java and so on. You can do pretty much everything. The regular expressions are also nice. The only thing is you cannot do the things like replace in a stream. What you can do the match part, then extract the regular expression, the capture groups, and then pass one or a few capture groups further in the stream. Later they can be used somehow, but you cannot do the replace that with that part. It's not implemented there. Join and lookup steps. In addition to what we have seen, there is also the possibility to call database.procedure to perform some lookup if you need. It's instead of select from a table, it performs the execute procedure and outputs the values to the stream. Then we are back to the job execution part. As Thomas showed you, you can define the job that was his example, which is waiting on Firebird event. We didn't do that kind of jobs in our case, because what we have there there is an enterprise job controlling application. It's basically controlling all the shell scripts that are executed over the enterprise, and on the timely fashion, it knows when to start it, or in what sequence it coordinates different hosts and so on. One example might be the cron job, but that's another job controller that we use. What is possible to do is that you can execute this transformation from a shell script. The kitchen is a tool. The user interface tool was called Kettle or Spoon. Now it's called Spoon. The kitchen is a tool to execute the job from the command line. You can specify the repository name there and the job name, and it just performs the job execution and returns via the exit code the value whether the job was successful or was not successful. There is a server called Carter where you can submit a job execution, and the repository is the database repository. That's two possibilities. Basically, you can execute the job in the kitchen. In that case, it uses this CPU to load the data. It has also to have the possibility to connect to all your data sources that you have in your transformations there. Or if you have a production environment and kitchen is some kind of another computer that you are using, then you can submit the job execution to the Carter server, and then you have to configure that the Carter server has the connections to different data sources that we have. So the Mondrian and Schema Workbench and Aggregate Designer. The Mondrian is the OLAP tool that was presented by Thomas. It can take the OLAP queries and transform that into the SQL queries and present the results using so-called XML protocol. And based on that protocol, you can use some kind of components. They provide a JPivot-based web application in order to access to do the drill down parts. The Schema Workbench is the user interface tool to define the dimensions, aggregates, and so on. And that's what I'm going to show you. We have about 10 minutes. It's Aggregate Designer. There it is. So that's a demo application which I used as well, the demo data. When you start the Schema Workbench, you have to first define the connection. They get some problems there, but with the fresh start, the connection can be defined there. Basically, what you have to specify is the JDBC driver, the database, the username, and the password. And you can then define the dimensions and the sales. What we have there is that we have, for example, the cubes. It's the part that was presented similar to what Thomas presented. The cube is a collection of basically the fact table. You define the fact table, which you are going to slice in different parts, and then you can reference different dimensions, which might be defined on the global level, or then they can be defined as well here. You define also the measures, different measures with different formatting parts, and so on. And it is possible also to define the aggregates here. And these are the aggregates parts which you saw in the XML file. So that's basically the user interface that allows you to define that cube definition the same way as can be done in the XML. You have to read the documentation. There is a documentation from Pentaho which describes the concept of that part, because which have to be defined where in order to get things running. It was quite hard for me. We don't use at work a lot of OLAP parts. We are mainly concentrated on the ETL parts. So, but compared to the kettle, this was quite complex for me to get that up and running. The nice thing, if we switch back to the concept of, where is the presentation here, is the Aggregation Designer here, which is a helpful tool which allows you to design the aggregates, and that's how it looks like. It's somewhere here. When you start the Aggregation Designer, you have to select the database, which we have already defined there. Then you have to load the definition, the OLAP cubes definition, which is here. And you have to select the cube that you are going to optimize. In our case, that is the sales. You press the connect. It loads additional information. And you can run the advisor. The advisor, you tell, it's using some internal constant, but you tell how many aggregates you want to have there. And the runtime, let's say seconds, 5 seconds, recommend. And it computes different combinations of what can be aggregated there. So, for example, it tells that it is possible to create pre-aggregated table where we have a data pre-aggregated on the year level and the product family and the country and the gender. And it will, based on the current data in the database, it will need 18 rows, and the total space will be 1 kilobyte. It's nothing like that. Quite simple. And then it may be another pre-aggregated table based on the store, square feet, the year and the country. And if you say export, you can preview the scripts, and it tells what tables to generate, what the tables should be generated there. It's the script to create the aggregation table. It is also the execute. I don't want to execute that as well. Oh, why not? Token unknown, line 5. Yeah, most likely, yeah. We have to rename it. We are going to export that into the SQL file. SQL. And we can also change the Mondrian scheme definition as well with these aggregates. But I want to show you first the populated SQL files. And what it does, it generates the insert statements with the appropriate selects and so on. So you don't have to write that by hand. The only thing is that this is a snapshot population. So basically it deletes everything from the table and populates it again. For the eager population of the aggregate tables, you have to use a manual process. Normally, for example, you cannot perform the computation of the average value of some column based only on the information from your new record and what is stored in the aggregate table. the previous average value. You have also to have the number of records on which you have computed this aggregated table. Then you have to multiply, add, and divide again, and so on. It can be used also for the lazy population when you start your when you schedule the population of your aggregate tables somewhere in the night. You can then just drop all the table in the aggregate tables there. The slice and dice application is also there, but it's not that nice. It looks not that nice as compared to the OpenEye application that was presented by Thomas. It's the same idea. You have the cube. You can drill down, and it computes. You have to you can sort the data there. I don't know if I have the output. No, it doesn't produce the output block. But the same idea. You can see the query there with that application. The only thing is that you can modify parts there, and it gets a bit bigger if you drill down and so on. That's only the selection part. Yeah, that's about the open source tools which can be used with Firebird from the VI part. As I say, we are mainly concentrated on the ETL part, which is mostly interesting for us. Thomas is mainly on the reporting part, so things are quite complementary there. Any questions? Yeah. Yes, but you have to transform the values. And there, if you have there, wait a moment. It's implemented in the fourth version. I can start the fourth version. The only thing is that I don't have the repository for the fourth version. Takes some time. On the other hand, at least with the data that we have, I mean, fetching the data via the web service, we never needed it. Somehow it's cheaper to put the data on the source system, to extract the data on the file system in the comma separated values or something like that, transfer. Computation services lookup. If you need to do this, that's the lookup. But the performance will be low. Okay, I mean, if you have to do this, then you don't have any other choice. But I would really consider about doing it somehow different. I don't know, maybe to extract the data, put them into a file, transfer a file to the place where the web service is running, performs the computation there quite fast for the whole batch, and then get data back. Because submitting each record over via the web service and getting the result back is just a costly operation. If your web service is designed the way everything is calculated, you do
some data, we do really huge calculations on it, and you get statistics back in time. Those statistics we need to do some slices, whatever. But it's too complicated to replicate all the business functionality.
No. I didn't mean to replicate. So basically, your web service is the input.
Yes.
is the input source
it's not persistent data that it gives out, it's really already
pre-processed, and what you have to do, why do you need to get the data stored somewhere? Why can't you access it directly? I mean, if that's an input system, because the main idea here is that you get some data from the raw data, you transform them, and you store them somewhere there. But you don't have any transformation needed at all. You have the web service that produces you the final data. What you are going to do there, if the data are already prepared, or what kind of data you produce. So basically the fact data are produced. And the dimensions are already there, persistent, and so on, and you just get the new facts, which are complex pre-processed. The easiest way you can extend it is to get the input. Another possibility is that you have basically it will act also as an input here. You can specify the URL of the VSDL. I never tried it. I know that it works, but you have to define the rows which you have to get, the operation name and the repeating element name, which will then get extracted. So if your web service produces an XML output, the message where some kind of record is repeated many times, then you have specified the name of this element there. Then it will produce as an output the parts. Okay, then thanks a lot.